Alright, so law of cosines is usually found with this formula, right? And then they expect you to just plug it out. Okay? Now, books don't typically give you this next formula. But see, as I don't really follow the book, I like to give you the formula. Let's figure out the new formula. Because sometimes we use the law of cosines. The reason we're going to use the law of cosines is because if you have the angle and the side opposite of the angle, then you use law of sines, which we talked about with last period, but we'll talk to you about in about 10-15 minutes. But if you don't have the angle and the side opposite of the angle, you have to use the law of cosines. And remember, law of cosines and the law of sines are used with non-right triangles. Okay? So this is the typical formula. But if you're looking for the angle, that means you have to plug all this in and then move everything out. And what I like to do is create two possibilities. One is with finding a side, right? And two, so like before with right triangle trick, for finding the side, we use SOHCAHTOA. If we're finding the angle, we use the inverse of SOHCAHTOA, right? With law of cosines, if we're finding the side, we use the ABC formula, okay? Now, if we're looking for the law of cosines with the angle, then we're going to do this. We're going to square both sides. So this is really b squared is equal to a squared plus c squared minus 2ac cosine b, right? So all I did is get rid of the radical. Okay? Squared both sides. Okay? So what I did here was I said, hey, if I square this and I square this, then this cancels this. Right? 18. Okay? Next, I'm going to move these over. If I move these over here, I just change their signs. So in essence, I'm going to go minus a squared minus c squared minus a squared minus c squared, and I get b squared minus a squared minus c squared is equal to negative 2ac cosine b. Right? Now, I'm going to divide by negative 2ac. But what I do to one side, I do to the other. Negative 2ac, right? And then I do something very ingenious. So what I have here is b squared minus a squared minus c squared equals cosine b. And what I'm going to do here is get b alone. How do I get b alone? Inverse. Inverse. Right? So I take the inverse. So now b is equal to the cosine inverse of, oops, this was all over, sorry, got excited, went too fast. This is all over negative 2ac, right? And so now I'm going to find the cosine inverse of b squared minus a squared minus c squared all over negative 2ac is equal to b. And this is my new formula. Okay? And the new formula can be written, I'll write it over here, so, and then I'll put the thing on there. So I have cosine inverse of b squared minus a squared minus c squared all over negative 2ac, right, is equal to b. Okay? So this and this are correlated. So, what if I was looking for a? Oh, Well, angle A would just be cosine inverse of A squared minus B squared minus C squared all over negative 2BC. They're right above each other. These are right AC, right? And then, well, what if I was looking for C? Okay? Well, that would be cosine inverse. Just put that over here and zero in on it real quick.
Well, you want us to write that?
I would. So you have a formula for each one. So I would come over here and go cosine inverse of C squared minus, and then A squared minus B squared all over negative 2. And then see how these two are above B over B, C over C, A over C, A over A, C over C? Same thing. A over A, B over B, and we're good to go. And so these are all the same formula for different parts of the angle. Okay? Personally, just deal with one of them. You can label these A, B, and C all on your own. Right? And so, are we done taking these notes? Because I got to erase these soon.
Yeah. Oh, wait.
Okay? So when we come back, when we come back to the actual problem, right? We have what I'm really looking for here is not this stuff, right? I'm trying to use this. B, right? Because I'm looking for B, is equal to the cosine inverse of B squared minus A squared minus C squared all over negative 2AC, right? And so that's just this. No big deal. Okay. Now, we can actually do the problem. I don't know this angle, so I'm looking for it. B is equal to the cosine inverse of B squared. This is B. Little b is always across from big B. Okay? Please stop, guys. You should be writing a lot. Okay? B is across from big B. And so we have B squared, which is 16.5 squared minus A squared, 10 squared, minus C squared, which is 14 squared, right? Divided by negative 2 times A, which is 10, times 14. Okay? And then you just plug that in your calculator. Now, the plugging in your calculator, that's the hardest part to this thing. Believe it or not. Okay? You have to learn some tricks. Alright? The tricks to this calculator is plugging in the top, right, as a whole, finding the answer, and then using the answer to divide by the bottom. But the bottom you have to divide by the whole quantity. So how I would do the top is I take 16.5, hit the square button. Okay? That will square, it puts a little square on the top. Then minus 10 squared minus 14 squared. Right? Then hit equals. That gives me 23.75 negative. Okay? Divided by this quantity. Remember, I'm going to push some certain buttons here. What I'm going to push is, I'm going to say divided by. Well, that'll take that whole answer and divide it by what I'm going to do. But it'll only divide it by the first number unless I put in a parentheses. Alright, so then I put parentheses. -2. Not -2, -2. Times 10 times 14. In the parentheses and hit equals. Okay, that gives me an answer of 0.084. Right? Now, I want to take the cosine inverse of that answer, right? So what I have to do is say second cosine. That gives me that whole cosine inverse thing, right? But then I'm going to use the second and negative sign to look for that ANS button, because it takes the answer. And then hit equals. And I come up with 85.1. Which is really, really close to the 85 we were looking for, right? Okay? So, we've been using the same numbers on all of these examples. Okay? So, law of sines, law of cosines finding a side, and then law of cosines finding an angle. Okay?